In this video, we're going to look at composite figures. So for definition, composite figures are figures that are mixing multiple polygons or other shapes. So this is where, with all the formulas we just learned for area, circumference, perimeter, with these images, it's going to be combining multiple rules together. Now, perimeter is still just going to be going along the outside, so usually we can start there, but when we get to area, that's typically where multiple formulas will need to be combined together. So let's look at this first image. Now, with these composite figures, sometimes there's one way to look at it, sometimes there's multiple ways, so maybe you can try this out for yourself first, and as long as you're using the rules correctly, you should get to the same perimeter and area at the end, but there are definitely more than one way to answer these sometimes. So with this one, in terms of perimeter, and I'm just going to start kind of sketching things. So what's going to happen is sometimes there will be unknowns that we need to solve for. So with perimeter, I'll be taking the 7 yards, and the 6 yards, and the 4 yards. Then I have this piece right here. I'm just going to put this in a different color. This piece here, we actually don't know the length of, but then we have this piece. So in terms of perimeter, I'm just going to map this out. I know I have 7 plus 5 plus 6 plus 4, and then that unknown side length. So I'm missing a piece. Now what I'd want to do is see if I can figure it out, see if enough information is given to me, which at this point, there isn't enough information. So with that, I'm kind of stuck right there. So maybe I'll start thinking about area, or I'll see what other pieces I could use. Now for area, it'll help to separate pieces, and maybe you'd start drawing squares, or maybe you're looking at a trapezoid. What I'm going to do is just drop this line down right here so that I can see I have a rectangle and a triangle. So in terms of calculating area, what I'm going to do is take the area of the rectangle plus the area of this triangle that I just made. And that triangle there with this line just dropping down straight, it's going to be a right triangle. Now, dropping this down, I did kind of separate this base line here. We know in total it's 7 yards. But what I could do is separate that 7 yards up based on that distance right there for this width of the rectangle should be the same as the number at the top there, that 4 yards. Now this image, it is not to scale at all. This is gonna, especially what we do in separating down here. And with these images, sometimes you just fill in numbers for calculations and homework and things like that. So focus on it numerically rather than the actual scale coming through. So if this is 4 yards right here, then my remaining distance, well, if it has to add up to 7, I would need to have 3 yards there. So with that, with this triangle, and sometimes what could help is separating, like just grab that triangle so we can look at it on its own away from the rest of the question. So we know we have 3 yards down here, 5 yards for the hypotenuse, and what we don't know is the height of it. And that scenario right there is perfect for the Pythagorean theorem. So what we can do is use our Pythagorean theorem. So our hypotenuse is the 5, and then the legs would be the 3 and our unknown. So we'd have 5 squared, hypotenuse squared equals x squared plus 3 squared. So we'll have 5 squared minus 3 squared equals x squared. Again, simplify this however you need to. Then taking the square root of both sides, that should leave you with a side length of 4. So with that, we found this little piece right here is 4. So we have the side of that triangle there. Now that we have that piece, now we can find our unknown here. Because what we have is in total, this length of the rectangle should be 6, and we know that 4 yards is being taken up by that side of the rectangle. So that piece left over, we have these 6 yards, but take out those 4, so that should really be 2 yards right there. So what we can do is for perimeter, we pretty much have it all done. We just need to add on 2, where we didn't know what the answer was before. So with that, we should have a total answer of 24 for the perimeter, and then the units would just stay the same. Now with that, we can find our area. So for the rectangle part, we have a 6 by 4 rectangle, so that'll be 6 times 4. And then we need to add on the area of the triangle, which is a half times base times height. So 1/2 times the base of 3 times that height of 4. And then we can just plug all that into the calculator, and that should be 30, and that would be yards squared. So it's just a matter of finding the pieces. You might need to bring in Pythagorean Theorem sometimes, but getting the missing pieces so you can calculate your perimeter and area. Let's look at one more with this ice cream cone here. So we have a half circle and a triangle working together here. So in terms of perimeter, what I can think of is we'll have this 6 feet, we'll have this 6 feet, and then in terms of outside the image, we have this unknown half circle circumference right there. So actually we could go ahead and find that right now, because we have, let's see, we want a half circle circumference. What we know is we have a diameter of 4. So for circumference, the formula is usually pi times diameter, which is 4, but we want to cut that in half. So what we're going to do is get a 6.28 from that. So that'll give us this distance here. So with that for perimeter, what we can do is we'll have 6 feet plus 6 feet plus the 6.28 for a final answer for perimeter of 18.28 feet to match the units there. So that'll do perimeter. Now area I want to calculate with, we're going to take this area of the half circle plus the area of this triangle here. So we'll have a half circle plus triangle. So half circle, so a circle in general is pi r squared. Now with this, if it has a diameter of 4, then the radius is 2 feet. So we'd have pi, and then r is 2, which we're squaring. And then because it's half of a circle, we just want to make sure to take half of that value. So that'll find our half circle piece, just that calculation there. Then for our triangle. So in terms of base, we have 4 feet. Height is unknown. So if I just map out height, I'm going to start at this vertex here, and then as best as I can for a sketch, just drop down that perpendicular. So that has a height that I don't know what it is yet. What I could do is kind of like I did up above there, is I'm just going to think about this triangle here. I have this kind of tall triangle that has the base that's the radius of 2 feet, hypotenuse of 6, and then the height is the other side. So what I can do is solve for height using that Pythagorean theorem. So let's see, the hypotenuse is 6, so that'll be 6 squared equals h squared plus 2 squared, which means h squared is going to come from 6 squared minus 2 squared, and we're going to take the square root of that. So for height, we should be getting a height of about 5.66. So then with that, for area of the triangle, it's 1/2 base times height. So we'll have 1/2 times the base, which the total base of our triangle is 4, times the height, which we just found, which was 5.66. And then throwing that into the calculator, we should get an area of, oops, zoomed in there very far, area of 17.6 feet squared. So that's how we can find the pieces. Sometimes you'll just need to break it down and look at the smaller pieces, putting it together in the larger scale. I do recommend, especially with area, breaking it down like I did here and thinking about what shapes do you need to combine together so you can see how you use different formulas for different spots.